Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and this week I'm joined by Lena.
Hi, I'm Lena. I'm a first year maths and CS student at Oxford, and I'm studying at St Anne's College.
Yay! So we've got Lena here to help with some questions that we're going to do today. We're going to do some MAT questions like always, but first, a quick shout out to people in chat who are going to let me know if I've forgotten to unmute or if I'm not actually live or stuff like that. Lena, you've just finished first year. How was first year? What did you learn? What did you enjoy?
Yeah, I really enjoyed the year. It's difficult, but it's really fun. It's worth it, obviously. I really enjoyed the CS courses. There's a lot of programming. Like we do two types of programming: imperative programming and functional programming. And functional programming is probably unlike any programming most people have done. I'd never done it before uni, but imperative is probably if you have programmed before, the one you've seen before. Yeah, I really enjoy both of them, and uh, there are quite a few interesting courses like design and analysis of algorithms. So there you learn about like the algorithms you're programming, and you actually get to implement them.
Nice. So imperative programming is the one where you write instructions for your computer, right? And then
Um,
functional. No, wait. I don't know why I'm trying to comment. Sorry. Go.
yeah, that is. So functional is more like maths, in like you write a function and then a recursive function or something. Whereas, yeah, imperative, like you said, is that uh, you tell it step by step what to do.
Fair enough. Okay, yeah. So step by step is maybe the only way I think about doing computers because I'm not a computer scientist. Cool. Okay. People in chat say that the live stream is working, which is technical brilliance. We've had while we were setting up, we have had a slightly patchy experience with the Zoom call that's connecting Lena to the live stream. So if at some point Lena's video drops or goes glitchy or freezes, then that's the Zoom. That's Zoom for you. Cool. Someone in chat says I've made a mistake already, which is I think a new record because we've only been live for a minute. So but I've made a mistake on the worksheet. If you'd like to see the worksheet, it's going to appear on screen. You can get your own copy right now at the Mat Live website, www.maths.ox.ac.uk/r/matlive. That's also got a solutions document, which you might think spoils the fun. But actually, it's there so that you can check your answers ahead of time or afterwards, and we've got some sort of written thing that isn't just a video live stream. Apparently, it's got at least one mistake in it already, so that's good. I'm out by one, which is a classic kind of CS error, right? I've at some point I've said CN when I meant CN plus one or something like that. There's questions about interviews in chat, which reminds me that I should talk about interviews a tiny bit, but I've also remembered to do the "How was your day" poll. So, chat, let me know how your day was going. I should also check. Lena, how's your day been today?
Yeah, it's been good. Well, I've prepared for this, and then went on a walk before.
Nice. Out of,
It's
out of
good, yeah.
five stars, are you thinking about like three or four there, or is that a full five?
Um, 4.5.
4.5. Cool. Right. So people in chat are voting on a poll, which we always do because I like to get the mood of the room before we launch into the mathematics. 5 is currently winning, which always excites me. I'm always watching out for people who vote 1 star or 2 stars, right? Easy for interviews. Lena, if you've got any advice about computer science interviews, we could do really quickly before we jump in. Just put you on the spot.
Yeah,
Sorry.
my main advice would be just to practice talking with people about it, like even your classmates, and um, yeah, just look up the computer science interview practice questions. There are loads of them online that you can find, and just practice them with your friends, and you can do one back for them, and do like just practice chatting about it, because I think the really important thing is just talking about everything that you're writing. So you need to be able to like say very well what you're thinking. So just make sure to say everything you're thinking out loud.
Nice. That works for maths interviews as well, of course. People maybe don't expect that they should be expected to talk out loud, but it does help if you can explain what you're doing. Sometimes it's quicker than writing, which is nice. There's someone in the chat asking about computer science and philosophy in particular, which is not a course that either of us on screen do. But my understanding is that for joint honours courses, it's quite normal to have separate interviews where you might have a CS interview and a separate philosophy interview. Lena, I don't know, for maths and computer science, did you have separate interviews?
Yeah, I had separate interviews. I think everyone who I've spoken to who does maths and philosophy did too. So you usually get, well, I had 3 for maths and 2 for computer science, but I think I had more than average. But you just get a few different, you usually get 2 different colleges as well. So
yeah, and also we like to interview people at more than one college, almost all the time if we can. 4 and 5 have drawn in the poll, and nobody's voted 1-star or 2-star, which is, I think, a first. So the mood is high. People are maybe excited by the prospect of a day that's got some computer science questions in it. Questions in chat. One's for you. One's how did you pick your college? You said you're at St Anne's College at the moment?
Yeah. I just looked at all the websites, and because I was in the year where you couldn't actually visit because of COVID, so I looked at all the online tours and stuff, and I watched the admissions video, and St Anne's looked like a really friendly college, and like the people looked friendly in the videos, and it had a very welcoming vibe. So I was like, I'll pick that one, and it is really welcoming and friendly. So yeah,
has it turned out to be welcoming and friendly now that you're there?
Yes.
Oh, thank goodness. It's a live stream, anything can happen. But wouldn't it have been funny if you said no? Right. In chat, people are addressing the elephant in the room, which is we're about to talk about a bunch of question 7s. I've picked out 4 question 7s for us to look at over the next couple of hours. Lena's had a go at them, and we're going to talk about the way we'd approach them. This year, 2023, there's no such thing as question 7 anymore. The computer science department have actually decided that people are going to do question 3 instead. So the people who would have done question 7, computer scientists, are now going to do question 3 instead, which is actually what the maths and computer science students were doing before anyway. So Lena wouldn't have done question 7, right?
No,
yeah, I should maybe have thought about this a little bit, but hey, I've got you onto a live stream to do questions that you wouldn't have done in the maths. Something I'm going to try and mention along the way is reasons why math students or computer science students might find these questions useful practice anyway. So there's a question in chat about like what's going on, why are we bothering, and are there going to be any questions like this, which I guess fair questions, right? I'm doing this on purpose. I think these questions are good, and I think we can learn from them. Someone in chat says, Shane, question 7 has always been my favourite, so we can do this as a kind of question 7 spec special. Anyone can sit the MAT if they're applying to Oxford. Why is the MAT so hard? Says someone in chat. Well, okay, so we can do multiple reasons why the MAT is so hard. It's kind of got to be hard because the people who take the MAT are people like you who are really good at maths, and we've got to use the MAT to help us decide who to shortlist. Okay, I'm slipping a little bit into just talking to chat, which is very rude of me. Let's start doing some MAT questions. That seems like a good thing to do with Lena. Lena, I think you're in the whiteboard as well. Can we just check that we've got that working?
Yeah.
Professional live stream. We should maybe have checked this before we went live, but hey. So maybe I'll read out the start of the question, and then I'll throw over to you to talk about the parts of the question that are just off the bottom of the screen for me at the moment. The question's about tiles. It's about a collection of tiles, which I guess look like these rectangular things, and we're going to make a match where the string along the top has to be the same as the string along the bottom. You can repeat tiles in your list. You have, I guess, an infinite supply of each of these. And this, it counts as a match because along the top it says AA, BAA, and along the bottom it says AA, BAA, if you smush all the tiles together. Lena's been given a complicated set of tiles and is going to try and make a match using these tiles, and there's some other bits of question as well, but the match has to have the same top string as the bottom string. Okay, over to Lena, I think. What are we supposed to do?
So the first part of the question asks what tile a match must begin with. So for a match, for something to be a match, obviously it needs the same on the top as the bottom. So we want the first two letters to be the same on the top and the bottom, because every letter has to be the same, but because the first two are always going to be in the same place, we need them to be the same. And the only tile that has the same on the top and the bottom in the first place is the U tile. Oh, my pen doesn't seem, it was working before.
I've got you.
Oh, there.
Oh.
Yeah, the U tile. So we need to start our tile with that for a match. And then the next part of the question asks us to write all the matches using 4 tiles. So another thing we note about a match is that a match has to have the same length on the top as the bottom. So this is gonna narrow down the tiles we can use, because we then need to make sure that the number is the same on top as on the bottom. And we know we're starting with the 3 U's. So we can, for example, I think my pen's working now, is that? Yeah. So we're gonna write the U tile first. We know that has to be the first tile. And we can look at the end tile. We know that they have to have the same letters at the end as well. So that gives us this tile that we could use, and the U tile again, because there are 2 U's, one on the top and the bottom in last place, and the 2 E's in last place, and they're the same. So we've got 2 possibilities. So if we start with the U tile, then we've got 4 on the top and 2 on the bottom. So, and we know the tile is going to have to be, we need only 2 more tiles here in between. So let's call this tile 1 and tile 2. So this is going to have 2 on the bottom, 1 on the top, using the tiles we've got.
Sorry, that last one is, that last one's E. You've written U over U, but I think you mean E over Z E for that last one, right? If I got. Oh no, sorry, you're talking about. So, no, I'm so sorry. I'll shut up. I've got confused, but I'll shut up. Everyone in chat, understands. Sorry.
Sorry. Yeah. So that yeah, this tile isn't going to work here, because if we put, the only way we can make the numbers match up is with the E over ZE's, and then the letters don't match up. So we know that the last tile now is going to have to be the E over ZE's, like so. So now we've got 2 tiles here, tile 1 and tile 2. So we need the numbers to be the same, so we can use either U and EZE, and we also need tile 2 to have a Z on top and something else on the bottom, and tile 1 to have a U on the bottom and something else on the top. And these 2, the alpha has to be the same in both cases. So the only tiles that this matches for are the ZX XU tiles and the ZY YU tiles. So this is a match. Oh, sorry, that is a match. And then this is also a match for 1 and 2. So that gives us the 2 matches of length 4. Does that make sense?
Throw to chat. I'm really sorry I interrupted. I hadn't spotted that the UU over U tile could possibly be the last tile. The web solution needs an extra sentence in it. Thanks, Lena. That's why I get computer scientists on to do this computer science questions. Yeah, so you had to rule out that case that I hadn't considered at all for that UU over U tile to be the last one. You're right, that's too long. How do we feel, chat? Just 2 possibilities for what to stick in between those 2 tiles, though. You've got to balance out the extra U at the front and that extra Z from the end. Cool. Chat is either not working, not keen, or mostly chat wants me to get rid of the background noise that's coming through my microphone. I will look into it. I've got more white noise recently. How about if I do that? Maybe that's slightly better. For now I've gone for a hardware solution of moving my microphone away from the loud thing. I'll keep muting myself. But also, I think people are happy that those are the 2 possible matches that use 4 tiles. Either you go via the X's or you go via the Y's.
Right.
3, I guess.
Yeah. So I've written all down the side of 3, but so for 3, we are replacing the ZE with the E over 3 Z's and an E. So we now know the length is going to be different, so we're going to have to match that length. So what we can use to match this, we could use, if I rub out some of this down the side, make some more space, we could use the U tiles like so, and then something else here in the middle, and then our new tile, which is the E, Z, 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 E. So, and this, if we use tiles of length 1 in the middle, then 1 on the top, 1 on the bottom, then we're going to have the number of the top and the bottom to be the same. So we could use this to get the smallest number of tiles for the match. Does that make sense so far?
So you're thinking about the length of the top and bottom streams, top and bottom again.
Yes.
Yeah. So Tracy in chat says, sorry, how can the case ending in UU over U have the same length at the top and the bottom? And it turns out that it can't. So Tracy's asking about the previous part.
Yes.
I interrupted you at just the wrong moment for this, right?
Yeah. So that couldn't have worked lengthwise unless we used the E over ZE tile in the middle. But obviously that didn't work for our cases. So
that was a bit of a dead end, right?
Yeah.
You were right to consider maybe the UU over U tile is the last one, but it turns out to be a dead end. I was wrong to not consider it at all. The 2 cases that we end up with, Tracy, are one of them involves the letter X and one of them involves the letter Y. There are these pairs. You could stick the XU tile and then the ZX tile, or you could use these 2 tiles at the end. Either way, the thing in between cancels out, either the X or Y, and you end up with a U downstairs and a Z upstairs that's just right to balance out as those middle tiles. So that's why there's 2 cases, not because of the possibilities for the last tile, one of those turns out not to go anywhere, but because there's 2 possibilities for the middle. And someone else in chat asks if there's any books about MAT as a whole, and if you print out all of the worksheets, it kind of functions like a book. It's got revision material in, it's got questions, and it's got hints. If I was going to write a MAT book, that is the MAT book that I would write. Cool, okay. Shall we carry on? So you're thinking about length again here. and you've decided you've got to use quite a lot of the UU over U tiles.
Yeah, so if we count up now, the length on the top, if we ignore the middle scribble bit, the length on the top is now 7, and the length on the bottom is also 7. So we've matched the lengths now with the U tiles. So we can now just use the tiles of length 1 on the top, 1 on the bottom, to get rid of our excess Zs and our excess Us on the top to make it match. So to do this, we need 3 tiles with a Z on the top and something else on the bottom here in this place to get these 3 Zs to cancel. So we need 3 of those. And then on this side, we're going to need 3 tiles with a U on the bottom and something else on the top. And the something else doesn't necessarily have to be the same something else, which we're going to see in the next part. So just as long as they match on the top and the bottom. So we're also going to need 3 of these to cancel out the U's on the top. So using this, we've got 3 tiles here, 3 tiles here, 3 U tiles, and 1 E over Z, 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 E tiles. So we've got a total of 3 plus 3 plus 3 plus 1, so 10 tiles.
Nice. I suppose we should probably check that the mathematician in me, right, wants to check that there is a solution that actually works with 10. Like, if I was being evil and I took away all of your X over U tiles and all of your Y over U tiles, then there wouldn't be any to use. But I think you've got enough X over U. Yeah, maybe it's useful for the next part actually. Should we try and write out an example of something that works? I think my pen lets me write smaller than yours, so I'm going to write something out over here, but maybe you tell me what to write. I've got to put the UUs over U first, right? And then just to demonstrate this kind of thing where you're talking about these 6 tiles in the middle, the first ones have got to kill off the U's. And it is possible to kill off those extra U's. Oh my goodness, my handwriting's getting worse and worse with each tile. There we go. It is possible to kill off those U's. For example, what am I going to put here? What should we put as an example?
So we could use here the XU tile, and then we could, for example, use it 3 times, but we could also just use XU and then YU, then XU again.
Yeah, I like that example.
Show
I think.
They can be different.
Yeah, they can be different. These ones are just here to kill off the extra U's that we had from the start. And then I think you described having 3 tiles that we're going to over here get rid of the extra ZZZE.
Yeah. So here we could use the tiles because the X, Y, and X have to match again. We could use ZX, ZY, ZX.
Brill. Okay. I think there we go. Just fitting it in the gap. Don't worry, the actual mat does not require you to write in the gaps between the questions. That would be silly. That's just our format for the live stream of trying to get everything on screen at once. Good. Okay. Someone in chat says these questions are just so satisfying when you get them, and maybe people in chat have just had that moment because, Lena, you said something really interesting in the middle there, that the X's and Y's have to like agree or match between. Maybe I shouldn't use the word match.
Yeah. So. Yeah, at the bottom 3 have to match the top 3. So so that's going to be useful for the next bit where it says how many different matches are there using the smallest number of tiles. So we can basically pick X or Y for any of the 3. So if we look at these 3 tiles, we can pick any X, Y, X combination, or X, 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 Y, 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 for example, just any combination of X's and Y's. So that gives us 2 to the 3 different combinations to pick here. And then as long as this pattern is the same on top here, then we have a match. So this gives us 8 different combinations for matches.
Sounds like binary choices. Computer scientists love binary choices. And I think once you've written out one example, you get this idea that lots of your tiles are kind of forced, like you're forced to do some things like this. But
Yeah.
what am I saying? The other ones have to. There's some restriction on. You get some freedom and some restriction. Being able to keep track of where you've got freedom and where you've got restriction is the kind of the game over here, I suppose. I've just realised there's a hint. It says you might find it easiest to construct your matches backwards and right to left. Did we do that?
Yeah, I mean.
I guess we did, yeah, because you talked about the Z's on the right. But your idea about length was. So we thought about this question in different ways. I'm not sure how useful this is to get my opinion on it. I'm not a computer scientist. But you jumped straight to length as an idea for something that was the same about the top of the bottom string, which lets you look. After you talked about the rightmost tile, you talked about the stuff going on with the UU over U tiles. Which is sort of global property of all of the tiles together. Whereas when I was thinking about this question, I just worked one tile at a time, going right to left. Don't know if that's like.
Oh, right, yeah.
Maybe I'm making a big deal out of this, but maybe that's like the difference between imperative, just follow your instructions, follow the matches one at a time, versus having some sort of more holistic view of properties of the tiles overall.
Yeah. Yeah, that also, I think that would have been, that's the solution they probably wanted then, the working from the right to the left.
Oh, I don't know. There's usually more than one way. More than one way. It's supposed to say 2 to the 3 because, and then they've put some explanation of why it might be 2 to the 3. Do you want to explain your 2 to the 3 for your choices just one more time? So you got this 2 to the 3 because there's 2s and 3s.
Yeah, it's because so we've got at the bottom of the Zs, we've got 3 places that we can choose an X or a Y for. And for each of these places, we have 2 different possibilities, X or Y, in each place. So, so it's 2 possibilities for the first tile, times 2 possibilities for the second, times 2 for the third. And that gets us 2 to 3 possibilities in total, so 8.
Cool. So there's those choices about X or Y. I'm going to write something kind of stupid. So it's like, no, I'm going to not write my stupid thing, I've decided. I'm going to say it out loud, but writing is for serious maths, right? X or Y to the power of 3. You've got these choices about what the X's and Y's are. Once you've made those choices, it's kind of fixed. So I guess this pair, this first one here, and this one over here, this first one of the Z tiles kind of go together. So there's 2 possibilities of what that might be.
Yeah.
Good. Okay, it's not quite how the person in chat put it, and I don't know if we're disagreeing with the person in chat or not. I'm going to give them a chance to reply again in chat, just in case. And people are also talking about maths. And I've remembered that Jackie's here. Hi, Jackie. I forgot to introduce Jackie at the start. Jackie is moderating chat and replying to people in chat as well. Thanks, Jackie. I don't know if you're watching the stream. Good. What am I doing? I'm on a live stream, and Lena's here, and we're doing the next part. I think you've got your 8 choices. We're not going to list them all out because it takes ages to write them down. The last part is loads of X's, new tiles. Over to you.
Yeah. So the last bit is we've now just got 2 tiles, so we're going to have to, because it's only X's, on the top and on the bottom. all we need to think about is how many x's we have on the top and the bottom. So we know on the first tile, there are 7 on top, 1 on the bottom. And then on the second tile, there is 10 on top, and no, 10 on the bottom, sorry, and 1 on top. So if we use this, let us call this tile A and this tile B. So we've got, let us say we have x of tile A, and then y of tile B, and then if we take this, we know for the top we can form an equation for the number of x's on the top. So we could say 7x plus y is the number of tiles on the top, and we need this to be the same as number of tiles on the bottom. So x's on the bottom, sorry, not tiles. So we could have that being x plus 10y, because that is the number of x's on the bottom. Does that make sense?
It makes sense to me, but I'm going to let chat catch up. There's a little bit of lag between video being compressed and sent to YouTube, being sent around the world, and then people in Slido typing. I don't count the x's the same. Does it tell us the 7 and 10? Oh yes, good. Phew, we don't have to be able to count. Maybe we do have to be able to count, but not necessarily right now. I love that this is turning into a maths question.
Yeah.
I mean, it was always quite mathsy. Is it okay if I find it funny that you've chosen the letter X? We do some normal algebra with X's and Y's, right?
Yeah, probably was not my smartest choice of letter.
I think you'll find the question's already got 19 X's in it. People in chat are happy. They're mostly talking about what happens if you do or do not get an incredibly high math score, which is kind of a separate question. Cool, Tracy's happy as well. Good, right. Anonymous and Tracy. The two chat viewers know there's more than 2 of you. Cool, I should let you solve this equation, right? I can tell that I'm sort of holding you back from solving 7x plus y equals x plus 10y. Maybe at home you can feel that force as well, the force of simplifying equations. Go, Lena, go.
So we can simplify this to get 2x is 3y. And then from this, we now can say that because 2 and 3 are coprime and you need x and y to be an integer, so we can say that y has to be a multiple of 2. So let us call y, oh sorry, my page went a bit there, I'm back to the center. So let us call y 2k. So then we know that 2x equals 3 times 2k. So then x has to be 3k. So now for our total number of tiles, we're going to have y plus x, which is going to be 2k plus 3k, which is 5k. So our total number of tiles then has to be a multiple of 5.
Very nice. I was wondering if you were going to say coprime or not. People in chat, have you met the word coprime? Have we done that on the stream before? I can't remember. While people are telling, yes, hello, so if someone in chat says, could you explain coprime to get y again? I'm going to let you define coprime. I've got a different way of thinking about this, just in case. But I'm going to let you explain coprime. Go.
So I define it as they don't have any common divisors apart from 1.
Yep, I like that. Yep, that's the definition of coprime. Lena's being careful because if you've got ax equals by for a and b whole numbers, it's not always true that y is a multiple of a, you can run into trouble if there's some common factors around. For example, I think this comes from like 6x equals 9y, but it's not correct to say that 6 and 9 are the relevant things you're supposed to divide. So Lena's, I guess, year of maths and computer science possibly, or maybe you already knew about being careful with co-prime numbers. Lena's got the training to check that. I've got a different way of thinking about it, which is just 2 times x is even, so the right hand side 3y has got to be even. If it's even, then definitely y has to be even. That's hard to generalise. Well, not hard, but it's not trivial to generalise that to other pairs of numbers. Here, 2 and 3, other numbers, other problems. It's not trivial to generalise that. That's why Lena's being careful and says words like co-prime. It's a good word to say. It gets you out of a tricky situation, but then, haha, it gets you into this new tricky situation where you try and have to explain what co-prime is. 9 and 10 are co-prime. Yes, chat. Maybe this has been mentioned on the live stream at one point where it's square root of 2. Someone in chat says they haven't seen all of the live stream episodes, and you're not alone. I think nobody has seen all of the live stream episodes. There are. Lena just smiled the smile of somebody who's maybe seen all of the live stream episodes, but no, you haven't seen this one because you're in it. There's at least 100 if you can't add them all up now. Good. So it's not okay for me to mention co-prime 2 years ago. I have to remember, even though people are still anonymous, it's not the same anonymous person. Cool, right, I'm being silly, which is a sign that we finished the question, and it's probably time to move on at some point. How do people feel about this? I like the kind of maths. I like the kind of maths bit at the end, where there's like some whole numbers suddenly and there's equations. Don't know how you feel about this question, Lena.
Yeah, I think that bit, it makes most logical sense. Like the last bit is quite nice just to get the equations to like give an answer rather than having to really hardly think about all the different letters.
Yeah. There's kind of like maze structure going on here. It makes me wonder what's going on in general with these matches of tiles. Is there some sort of pattern that we can put together for other configurations? I sort of wonder what's this supposed to represent? What is this like? Is it Lego? Is it a bit like Lego bricks that join together in different ways? Is it Lego? I don't really know what's going on. It could be Lego. Right, other brands of plastic interlocking toy are available. Okay, should we do another one? Let's do another one.
Yeah.
It's become locally, I don't know if you can see on the screen, it's become locally very sunny in Oxford, so I'm gonna do something about that in a second. But first I'm going to introduce you to the concept of an Oxword. That's right. Oxword, well, they're constructed following rules. It's a very computer science way of defining things, I think. Also, mathematicians like defining things like this sometimes as well. If you've met induction, you know about, anyway, doing things one at a time. So, Oxwords. First one I want to tell you about is the word with no letters in it, and that's an Oxword, I guess. And you're allowed to make new Oxwords by sticking an A on the front and a B on the end of an existing Oxword, or by gluing 2 Oxwords together, and that's how you build Oxwords. What, I guess, big question, what Oxwords do you get? What's the set of Oxwords? That's not actually in this question. Instead, there are 4 or so parts of this question investigating different properties of things. Cool, right, I'm going to get the sun out of my eyes and hand over to Lena to explain about Oxwords. Over to you.
Yeah, so like James said, so these are all the rules for the Oxwords, and so the question first asks us to show that every Oxword has an even length. So a way to approach questions like this is just to look at all the rules for the Oxword and show that if this rule holds, then it must have an even length. So I'm going to approach this like a proof by induction. So it's you'll have a base case, and then you assume something's true, and then show that for the next step, it will be true as well if the previous step was true. And then because it was true at the start, this must then hold. So if we do that for the first part, we show that every Ox word has an even length. So let us first look at rule 1. Rule 1 shows an Ox word of no length. So it's an empty Ox word. So that's going to have length of 0. And 0 is even. So it holds for rule 1. Now, for rule 2, we're going to use the induction step. So we're going to assume that W is even. So if W is even, we want to show that rule 2 gives an even word. So if W has even length. So this is the induction hypothesis. So now if W has length n, and n is even, then AWB has length n plus 2. So if n was even, then n plus 2 as well is even. So then this holds for rule 2. For rule 3, we've got now 2 words, U and V, and they're going to have length, even lengths as well of N and M. So we can assume this again. And now we want to show that our new word, UV, is going to have length of N plus M. And as N has an even length and M have an even length, then this is going to be even as well. So we've shown that from the base case, which is the empty word of even length of 0, every Ox word we're going to build up from that is also going to have even length.
Really nice. You mentioned, so I like the way that you work rule by rule, because those are the only things that generate Ox words. It's sort of a reminder of how important definitions are, right? The definitions give you what an Ox word is. If something follows the definitions, it's an Ox word. If it doesn't, then it's not. So you kind of know this property about all Ox words. Even, I guess we haven't actually listed any of them yet. We're about to list a few of them, but you've got the kind of property of all of them somehow by just looking at finitely many rules.
Yeah.
You mentioned induction, and I'm wondering whether I should head off the question in chat about mathematical induction. I think I'll let somebody type the question in chat about mathematical induction. I sort of hope that it makes kind of intuitive sense as well, in a way that because the rules are all about building something, and you build shorter words into longer words. Anytime you have an Ox word, it's come from somewhere. So although there's sort of an inductive structure, which someone in chat is now called out, asked the question, why is there an induction thing going on in here? Although it has a kind of inductive structure, I sort of hope that the way it's constructed is sort of clear enough, even if you haven't studied mathematical induction, even if you've met dominoes and things. That this idea of building things. Did we mention induction a couple of streams ago? Yes, we mentioned it quite a bit, because this idea of building up a sequence of things, it's just a really good idea. Do you think you could do computer science without induction?
No, not from. Definitely not on a lot of the courses. A lot of it does rely on induction, and a lot of the algorithms do.
A lot of recursion in even something simple like Euclid's algorithm or algorithms.
Yeah.
Those sort of recursive definitions of n factorial or something. Good. Induction is like climbing a ladder, innit? Says chat. There you go. Good stuff. And which sort of means that if you've seen a ladder, then you've kind of got all of the mental model that you need to get this. Induction's nice. It's almost like you could invent it yourself if you were doing a question that was laid out in an induction style. Right, good, okay.
Yeah.
This is to just this is to justify why it might have this kind of structure of building up from small things to big things. That structure is kind of unavoidable. Cool. Should we start actually listing some Oxwords?
Yeah. So to get to the Oxwords of length 6, we can build up from length 0 to length 6. So for our first Oxword of length, so if we write down length here, if we start off with length 0, all the Oxwords of this are going to be just the empty set, because there's only one Oxword and it's just empty. So now if we're going to take them of length 2, we can only use the second rule for this. So it's just going to be AB using the second rule, because the third rule, you need words already to make it. So now of length 4 we can go to. So we can use rule 2 and rule 3 to get the Oxwords of length 4. So let's use rule 2 first on our Oxword of length 2. So we're just going to get A, B. So that gives us our Oxword, and we did that using rule 2. And then we can also get AB using rule 3 by just using the first Oxword twice. And then for length 6 Oxwords, if we take this this word first, let's look at all the different things we can do to this word. So we can first use rule 2 on it. So that gives us A, B. We use rule 2. And then we could also use rule 3 on this word and the word of length 2. So if we do this, then we can put AB on the start to get A, B, B, or we can put it on the end to get A, B, B. So that is using rule 3. So that's all the different things we can do with the first word of length 4. And then if we look at the second word of length 4, we can again use rule 2 to get A, B, B. Or we can use rule 3 again to put AB on the front of our new word. And we can also put it on the back, but that's the same word. It's still AB. So this gives us 5 words.
Nice. I like you're working systematically and thinking about which rules you're using. You're never really using rule 1 anymore, I guess, because, well, it's a stupid observation, but rule 1 is only helpful once. Gives you the empty words.
Yeah.
And I guess, so you're working systematically looking at each of those 4-letter words. I guess you know that you need to use at least one 4-letter word. I guess I'm a bit worried when we get up to building, if we had to go further, right? If we had to build 8-letter words, then I suppose the system would be, if you're using rule 3, you've got to use 2 shorter words, not necessarily 6 and 2, but maybe 4 and 4. So I guess there's that kind of subtlety that you can, stick things together by looking at all the previous combinations. Sure. Okay. Cool. 5 of them. Sort of a weird number. Kind of morally feels like it could have been 6, but then 2 of them turned out to be the same. That's not a real argument, right? That's not how counting works. You can't say 6, but 2 of them are the same, so 5. So, but morally 6. Let's move on. I think. Have you got the same number of A's and B's you have so far?
Yeah. So the first part has been correct. Our piece was correct.
We've got quite a few of them now, right? We've got a experience of counts on board 8, 9 different Ox words if you count the empty string. But of course, that's not a proof for mathematicians or for computer scientists.
Yeah.
Let's do it as a proof, I guess.
Yeah. So for the third part of the question, we ask if the number of A's is equal to the number of B's. So to prove this, we're gonna look at the base case again. So this is our first rule. And it is just the empty word. So it has 0 A's, 0 B's. So 0 equals 0. This is right. So now if we look at rule 2, let us assume that our word W has n A's, n B's. And now we're going to make a new word, which is AWB. So now we're going to have n plus 1 A's and n plus 1 B's. And this is the same, so it's true for our second rule. And then for our third rule, let us say that U has M words, M A's, M B's, and V has N A's, N B's. Then we're going to have, for UV is going to have M plus N A's and M plus N B's. And so we prove that it's true again. And this is all our rules, and it holds for the first case, so it's going to hold for everything.
Nice. I like you're phrasing this induction again. Oh no, some of that was behind my head. My head was in the way. But what you said out loud was also good. That's why I got distracted by chat at just the wrong moment. Yeah. You phrased that like induction again, but again, I think it makes sense that you're building this up, and you're always keeping things equal as you do so. So that's good. Okay, the question takes a weird spin at this point because I think it's been quite straightforward so far. Is that fair? I think that's fair. It's about how you add things together, and even plus even is even, fine. Even plus 1 is odd. But if you add 1 to both these numbers, they stay the same. The question is a weird spin by telling you some information in the middle, which we do sometimes. If you want behind the scenes, sometimes there's because maybe there was a part of a question here that maybe was too hard, so it got converted into a statement. So maybe we can imagine a question where part 3.5 is proof that you can write these in this form. I've added an extension to try and resurrect that as part of the question. I've added it as an extension. Note that is not part of the MAT question. If you'd like to see the extension question and solution, they're on the worksheet over there. I'm not going to make Lena do that. Hypothetical part 3.5. Instead, part 4, which is talking about the number of Ox words of length 2n. Where am I going to zoom for this? I think I'm going to zoom in down here, like that. So we've got a load of space underneath. Okay.
Great. Yeah, so for part 4, we want to, we're considering Cn, which is the number of Ox words of length 2n. So first of all, the rule given that James was talking about is this AWBW dashed can express every Ox word. So this is given for a reason. We're definitely going to have to use it in the question. So we can make a note of that. So if we first, to start this question, look at the word AW, BW dashed. Let us say that the length of W plus the length of W dashed is equal to 2n. Then for this word is going to have the length of 2n plus 2. So this is going to give then, for every W is going to give C of n plus 1 if we consider every single W and W dash pair. So if we look at this, we basically want to look at every pair W dashed that uses this rule. That the length of them combined is going to be 2n. So if we say that W has length 2k, then so length of W is equal to 2k. Then using this, we can write length of W dashed equals 2n minus 2k, which is equal to 2n minus k. So if we look at this, we now want to look at every single W and W dash combination. So if we pick out, we want to look at the number of ways we can get a word of length 2k. So this is going to be CK ways. And the number of ways we can get a word of length 2n minus k is going to be Cn minus k ways. And the number of ways we can put these together is going to be CK times Cn minus k. And we want this for every k from 0 to n. So we've looked at some notation, if I'm correct already. So then we can write this as the sum from k is 0 to n of ck times cn minus k. And this gives all the unique forms to write a word of length n plus 1, 2n plus 2, sorry.
Nice. I muted myself at the wrong moment. I got thrown by these kind of factors of 2 at one point, and there's this. But no, you're spot on, of course. I've struggled to explain to people before. Maybe everyone understands now that Lena said it. But sometimes you multiply things and sometimes you add them. It's like surprisingly subtle, this difference between I've got all these choices to make, and sometimes I've got like this many words for there and this many words here, and I'm supposed to multiply and then add. And if you overthink it, or if you get too abstract, it's really hard to understand why you're sometimes multiplying and sometimes adding. Possibly me talking makes it worse, right? Because me talking in the abstract sense removes all of the context of these words that we're building. I don't know if you've got, can you think of any ways to sort of do a tip there? How would you justify the kind of multiplication or addition divide?
So for the multiplication here, it's because we're looking at the different combinations and their independence. So the first word is independent of the second word, whereas we're adding all the pairs because we know that we've already looked at all the cases where k is 0 by the time we're looking at k is 1 cases. So that's no longer independent of the other ones. We are looking at only pairs of that form, if that makes sense.
Sure, okay, so you've got kind of mutually exclusive cases for what's k, but then within your case you've got some independent choices. sort of adding between your adding between your mutually exclusive cases, but multiplying the options choices that you make within one particular subcategory. Okay, I guess multiplication is like a whole bunch of adding. So, in some sense, what's the difference? Someone in chat's asked a good question, which was, is AAABBB in that format at the top? It's given to us in the question, but it looks a bit like it's not. They say, am I missing something obvious? And someone else in chat says, yes, it is obvious. I think it's not obvious, because the only way to write that in this form is for this to be W and this to be W prime, the empty word on the end, which is, I think, a weird consequence of the, well, maybe not weird, but an interesting consequence of the empty word being an Ox word.
Yeah.
I guess to complete the pattern, I should give an example where W is the empty word and W prime is an Ox word. I guess this one is an example. AB, AB, AB. You want to put the A at the front, but then the only place you can choose one of these B's to be the B that splits the words. And the only way to do that is to pick this B immediately. So then W is empty word and this bit is an Ox word. It's actually unique. I think they say that over here somewhere. It's really unique the way to do this. So if you can't spot it, then it might be weird, but it is there. Not at all obvious why that might be for this question. You're allowed to say. Cool. What a neat formula at the end. It says take all your previous terms of your sequence, write them out, and also write them backwards, multiply them together, and add. It's kind of the dot product of the previous terms of the sequence and the reverse of the previous terms of the sequence. If you know about dot products, it's like adding up lots of cases on the previous thing. These numbers are famous. They're called the Catalan numbers. I think we've seen them before. Lena's nodding because Lena's seen the Catalan numbers. Possibly, do you actually see them in the computer science course? Are they?
I don't think I've seen them in the course yet, at least. But
Okay, these numbers are famous. I'm pretty sure I wrote Catalan on the board a couple of streams ago. I'm going to write Catalan on the board again. Oh yeah, they were in a warm-up question. They were in a revision question or something. Wait, it doesn't really count as revision to see the Catalan numbers. But I set this sequence. I foreshadowed this, I remember now. 2 weeks ago, I got them to calculate terms of this sequence. 2 weeks ago, they found the terms of the sequence. 1, 1, 2, 5, 14 or whatever. Here it is again. Same rule. Good, right, okay, so I like the way that falls out. And these numbers they turn up in loads of maths problems. They're like binomial coefficients. That's not an exaggeration, they're literally like binomial coefficients. Okay, good. Great progress. We've got another math question. I'm going to give chat a little moment to catch up, see how chat's doing. YouTube sometimes gives me terrifying error messages, so I'm going to try and encourage YouTube to blink and take a quick pause perhaps or break. If you would like to grab a glass of water or remember to blink, stay hydrated, all of those things. Lena, that goes to you as well. I always think 2 hours. Now that we do 2 hours, it's a very long time. We've got more math questions coming up in a second. Where's my extension? Oh, there's my extension. Prove that every Oxford. I've got a different interpretation. Full disclaimer, I didn't think of the other interpretation until I realised that they're Catalan numbers. Once I knew they were Catalan numbers, I realised that there are other ways to count them, other ways to do them. Sort of Catalan numbers turn up in lots of places, yeah. So it's unique because this is a bit silly, but the word W is you take all of the sequence until the B's are about to catch up with the A's again. You look to see the next B will cause the B's to catch up with the A's for the first time, but then you don't take that actual B. That's your word W, which is not something I'd have thought of by looking at the way that Oxwords are built. But oh well, good. Okay. I wonder if anybody in chat wrote down this expression in this sort of tidy way or with lots of dot dot dot. Lots of dot 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 is absolutely fine for us. Cool, okay. We've got another string question coming up in a second. I'm going to line it up on the screen. Is there anything you want to say about this question before we jump in?
I think it's really important to like note that as this question goes on, I mean, it's part of the question, but really it calls M and W separate letters and it like asks you about them, but in theory you can just swap them round.
Right.
So they kind of act the same. So we can kind of look at X as something separate to M and W.
There's a. I'm not sure if this is why they're using M and W, but I've got a really daft way of interpreting that, which we'll get to in a second. Yeah, but there's this kind of switch. The M's and the W's are kind of created equally. They have rules, but the rules are kind of symmetric. They're a bit like I was going to do a physics analogy, but then I realised that A, I'm going to make a fool of myself by saying some incorrect physics, and B, people will go, oh, physics. Like, matter and antimatter, right? They're kind of symmetric opposites, supersymmetry opposites, and you shouldn't put them next to each other. Ooh, physics. Right, okay. How's chat doing? Is chat alright? My chat has frozen, so if anybody said anything in chat recently, I haven't seen it. Cool. Always good to give Slido. Slido's been running for an hour as well, so we're giving Slido a little refresh. Remember, well, I'm remembering that I'm human. Slido's remembering that it is software. My computer is making unusual noises. Sorry, computer. I'll let you not use graphics so much for the rest of the week or something. Okay. Personal opinion here. The question starts with the word clearly, which I don't love in maths. You, the reader, should usually try and prove something if it says clearly, or at least think about it and think about why it's true. So I'm going to make Lena do that now, even though it's going to turn out to be easy because that's why it says clearly. But I'm going to make Lena do it now. Lena, please could you check that there are 3 valid sequences of length 1?
Yeah, so if we're looking at the length 1 sequences, we've just got M, X, and W, the 3 letters we can use, and they're all valid sequences because they don't, on their own, they don't have any rules about them. So we've got the 3 sequences of length 1 here.
Yep, nice, thank you.
So
I'll let you do the actual question as well.
yeah, to look at the sequences of length 2, we build up from these. So I had actually written down all the sequences of length 1 to look at this question. So you can build up from these, and we can just look up all the possible different possibilities and combinations. So you can have MM, and that's valid. We can do MX, MW, but MW violates the rule that they can't be adjacent. So we get rid of this one. Then we move on to the terms beginning with X, XM, XX, and XW. Oh, yeah, thank you.
Just adding slashes in between.
Yeah. So then we have, after this, we can look at the term starting with W. So W, M. And this is, again, not valid. So we cross this one out. Then we have WX and WW, which again is valid. So we end up with 7 sequences.
Very nice. Good. I like that 9's not too big, so you can just sort of list them all and check whether they work. We're about to do some pretty involved calculations.
Yeah.
I've seen a lot of computer science questions like this, and actually like the question 5 is sometimes like this as well. Explain why and then some equations. Desperately trying to remember whether the question 5 that Lena had to do on maths X many years ago was of this format, but quite possibly we got Lena to explain why some equations are true. I like it because you get to write some explaining stuff down. Over to you, sorry.
So for the next bit, we've got now new terms MN, WN, and XN. And each of these is a sequence of length n, which starts with that letter. So it starts with n, w, or x. And then gn is the number of ways in total you can get a sequence of length n, and it can start with any letter. So the first part of the question asks why mn equals wn. So if we think about this, we can have a sequence, any sequence here, and if we replace all of our m's with w's and vice versa, if we just swap them around, we've still got a valid sequence, because if we've swapped them all, then there must be no m's and w's next to each other. So that means that the number of valid sequences beginning with n must be the same as the number of valid sequences beginning with w, because they follow the same rules. So that explains why this one is true. Now for the next bit, we look at mn. So mn is just any sequence beginning with m of length n. So if we look at the different ways this can start, we can have sequence m, and then something else. This would be a valid sequence. And this m and something else can be any sequence beginning with m of length n minus 1. So we can write the ways that this can be made like this. This is the total number of ways that we can choose this word. Or we could have m of x and then something else. And this is going to have x to the n minus with n minus 1 different way, like different letters after the x. So these are the total number of different ways we can choose the next part. So it's going to be, so then we add these together to get this equation for n greater than 1, because if n was less than 1, if n was 0, then n minus 1 doesn't make any sense. So that explains the next bit. And then our final bit is, the next bit of the question, sorry, it's got more.
But wait, there's more.
So xn, we can look at it the same way by looking at what the next letter is going to be. But because it's x, it doesn't have any rules about the next letter. So it could be m, x, or w. So xn is going to be m n minus 1 plus x n minus 1. Oh, sorry, that's meant to be a minus. Minus 1 plus w n minus 1. And then we know here that mn equals wn, or in this case, mn minus 1 equals wn minus 1. So we could just get rid of this and just replace it with another mn minus 1. So we've now got two mn minus 1s. So this gives us this equation. So we've proved our three equations here now. And now we want to write down a formula for gn in terms of mn and xn. So if we first look at writing a formula for gn with using whatever we can, so we know that gn is just any possible sequence beginning with any letter of length n. So we know the three different letters it could start with are M, X, and W. So we can just write G N equals M N plus X N plus W N. And now we look at what we wanted it. We wanted it to be in terms of Mn and Xn. So we want to get rid of the Wn. But from above, we know that Mn equals Wn. So we can just write that Gn is 2mn plus xn. Just double check. Yeah.
I'm with you. I think. Yeah, that's good. So that xn, there's a nice coincidence, I guess, or maybe that thing you've just done is pretty similar to the thing you did before, where you switched the w for an m in an equation, which means that actually it's going to sound like the xn equation on the right here. I think this is literally g of n minus 1. They don't ask you to observe this, but I think this stuff over here is literally g of n minus 1, because we've got two m's and an x, so the same joke twice.
Yeah.
As you start to calculate these things, it turns out that that's true, that the x is always equal to the previous g. I think we should not calculate the numbers on the stream because I think there's a high chance that we get them wrong. But I think we could maybe talk about how you calculate the numbers, like what steps do you do as you calculate the numbers. It's also a verify question, so people can check for themselves that they've got 41 at the end of this maths. Maybe we should. The numbers are kind of nice. My pen lets me write quite small, so maybe I'll do some numbers. But let's focus on describing the strategy first, if that's okay.
Yeah. So in the answers, and probably the best strategy is that they've used a table to write out all the different possibilities. So you write out n, and then for 2, 3, and 4, and then you build up this table for mn, xn, and then gn. So,
we
can use this because it's quite easy to find m of 1, for example, because we know there's only one word that begins with 1, and so you can build up like this.
What order do I want to think about?
Yes. So mn and xn, and then gn would be the next. The last one, because we are going to be adding together 2 mn's and 1 of the xn's for gn. So are we planning on filling in the table? Or?
I'm going to fill in the table really quickly, but we're going to talk a little bit about the rules along the way. You did this one in the first. You've got n equals 2 from your working for the previous pi. I think this is 2.
Yeah.
This is 7, which is 2 times 2 plus 3. And then using these equations, right? The trick is we're using the equations. If you want m of 3, we've got an equation right here which says add together m of 2 and x of 2. These are true for all n. So add together, so literally just add together those two numbers, which I can do just about. And this x rule says take the previous values, double the x value 4, and add 3 to get 7, and then do that again. And I can just about do that again. And I could maybe laying it out in a table is nice. I haven't seen this table before, but you've described it very accurately, so I'm good. And then that turns out to be 17, and this is 41 over here. Oh, I did do it. Oh, it happened. Okay, no one believes me. Chat might have frozen, but goodness. Chat might have slightly frozen, but chat's back. Hi chat, how are you doing? You alright? Chat says, you'll like this. Chat says, I am trying to process all of this. Crying emoji, tears of laughter emoji. But I've learned that I'm going to say your generation uses the crying emoji different from my generation. If I'm okay to say generations, my generation crying emoji means crying. Your generation it means like, I don't know, really really happy or something, or overwhelmed. I don't know. Chat taught me about the skull emoji quite a while ago. That was a fun day. Learning emoji with Gen Z. Good. Okay. There's an extension question that I put together for this to say, have you seen these numbers before? Lena might not have, but if you've been watching the live streams for a few weeks, I think you've seen some of these numbers before. Cool. Okay. Love the swapping. Like these things where you generate them along the way. If anybody wants a little bit more overload, so not the person with the tears of overwhelming perhaps, but if you like matrices, there's a kind of matrix operation going on here. I'm just going to draw. I'm going to draw the matrix really small. It says 1, 1, 2, 1. Right. Okay. If you don't like matrices, just put your thumb over that bit or something. If you like matrices, there's secretly a matrix hanging out in the middle of this question. Right. Good. Okay. I should move on. People are laughing to the extent of tears. Skull emoji, says chat. Right. Good. James has put another typo in the solutions. Skull emoji. I see. I'm learning. Right, okay, we've got definition of a reflexive thing, and I'm going to hand over to Lena. Go.
Yes, so now we're going to look at the reflexive definition. So it just says to reverse the letters and then replace all the M's by W's and vice versa. So you're not just reversing the sequence, you are and then it doesn't change. So you are the examples above are given. So MXW, if you reverse this, we get WXM. And then if we switch the M's with W's and W's with M's, we get MXW, which is what we started with here. So this is what it means to be reflexive in this definition. So we want to find the number of valid reflexive sequences of length n. This is Rn. And the first hint we get to doing this is to think about what happens if there's an odd length. What has the middle letter got to be? So if we look at a sequence, reflexive sequence, so let's say this bit and this bit, and then we've got a letter in the middle. So when we reverse this is going to be reversed here and vice versa. So they're going to be swapped around, but this middle letter stays in the same place. So as M and W are going to change, we're going to have the middle letter to be an X, so that our sequence is the same. So for an even sequence now we look at, we're going to look at the same two letters, the middle two letters now. So we're going to have these blocks at the side. And then we're going to want two letters. So the only way we could get these, if we have an X and another letter, this is going to be a problem, because when you swap them round, it's not going to be the same anymore, because and we can't use an M and a W because they can't be next to each other. So that means we're going to have two X's in the middle again for this to work. So now if we want to look at the different ways we can make this sequence of reflexive strings, we can write this to be one word, and then, sorry, that kind of, my pen broke there a bit. So if we just use this to be one word here, and then we reverse it on this side, and we apply the reflexive, we reverse it and we swap the N's and the W's here, then we are going to have the same word essentially here. So we just need one word of half the length for the even words. So that means we just need R of n over 2. X of n over 2. And does that make sense for even words in chat?
Help us. So the word for that right-hand half has got to be valid, and it's got to start with an X. We cool? So this is going to be X of n over 2. I'm thinking back to the point with the tiles and how you had some choice, but then some stuff's fixed. So your yellow highlighted section, you're saying that could be any word, but then the stuff on the left is fixed after you've chosen that. It's kind of like
Yes, exactly.
yeah, you got some choices and then some consequences. You could think about it the other way around. You could think about it as the left string that you choose and then the right string that's fixed. Or if you're feeling crazy, you could kind of alternate between those and choose for each pair. But it gets a little bit complicated at some point, right?
Yeah.
X of n over 2. So I guess we've got the odd case still to go. Someone in chat says, looks like a normal distribution to me. I can't see the normal distribution, so I'm now playing a mini game of where's the normal distribution. Let me know in chat. But I think it's time to talk about the odd case next, with just that X in the middle. Over to you.
Yes. So the odd case, it looks, because if we look at it, we can just take out one of the X's and the word's still going to be valid because there's still an X in the middle. So it's not going to lead to any N's and W's next to each other that weren't already. So if we just use the even case and get rid of that X, for example, then we still have the valid word. So we can just do the same process as the even case and just get rid of one X. So that means we have X of n over 2, but because it's odd and we've got rid of a letter, we need to add 1 here. So add 1 over 2, and then that's here.
Nice. People have said I can read chat. They're talking to each other about normal distributions. I'm an idiot. I need to read multiple chat messages. They're talking about MAT results. Still talking about MAT. Sorry, chat's sort of having a separate conversation, but I haven't been reading out on the stream too much. Yeah. The histogram is on. If you go on the MAT website, there's a histogram. If you dig a little bit in the document labelled feedback, the feedback is written by mathematicians for mathematicians, and it has a lot of numbers and graphs in it. One graph and several numbers, more of a chart, I suppose. I was a little bit surprised. I mean, everything you said absolutely correct. You can remove an X, and now you get this odd length one. That struck me as a very, you're using your previous result, right? It's a cumulative building thing, right? You just did some work, and you'd like to shortcut for the next one by relating it to the previous thing you did. It's just something I've told you that happens a lot. Yeah, it is right. I think I was expecting you to grab the highlighter again as a different thing. You surprised me a tiny bit because I think I was expecting you to grab the highlighter, like highlight the right hand side and say, oh, this is a word of length n plus 1 over 2 and it starts with an X. So there's the word. And then, oh gosh, when it gets flipped and reversed, I actually don't want the other X. So, oh my goodness, it's all fine. So I've got this slightly clumsy way of doing it by pointing at the word and then making it work. Or elegant solution of doing the even case first and crossing it out. Nice. Separate question then. What's going on in this question? What's going on in this question? What is it? M and X and W? I've got 2 possible answers, I think. If you've got any guesses, I'll ask chat as well, I suppose. Any guesses? What's going on in this question? Somebody put one of my guesses in chat already, which is that M and W is a fun choice because for a reflexive string, you're supposed to write it backwards and swap the M's and W's. This is silly, but you can do those at the same time if you rotate the string by 180 degrees around the midpoint, because that reverses it and all the M's go upside down to become W's, and all the W's go upside down to become M's. So these strings are ones that you can rotate. Oh, that's not a curved arrow.
Oh, right.
The ones you can rotate about the middle. So I quite like this as an interpretation of what's going on. The odd ones are nice because that X in the middle is like a pinwheel. You go around 180 degrees. This one over here has got an X in the middle. The M flips to a W and the W flips to an M. So I think that's quite cute. This switch. One way to phrase the switch earlier, instead of just switching the M's and W's, also reverse it and say that you're doing a rotation. I think it's a bit silly. But there's another interpretation of what's going on in this question, which is a bit old-fashioned, I suppose, but when I read the start, I thought it was about gender. I thought it was like men, women, and non-binary folk. And then the rule is really old-fashioned. It's like men and women are not allowed to sit next to each other. So it's like a row of people sitting together. And non-binary folk are cool, but the men and women are never allowed to sit next to each other. So you're counting the ways that these people can sit down, which I mean I don't love, because then I don't get my lovely upside down thing, because if you turn people upside down, it's not the same. So I can't interpret the reflexive thing in the same way. But yeah, so we got 1 credit for 1 credit in chat for things upside down. Thank you, anonymous. Thing about being anonymous is that nobody knows if you're the same anonymous person later on. And somebody's got a kind of Cold War metaphor about things not being allowed to be next to each other, which, you know, I just said, but it's I guess of an era, right? Who'd have thought? Okay, cool. We've got 1 more question. Chat is talking about the Cold War. I've got an extension of this because my extension's a bit weird. I don't know if Lena, I don't know if you learn this sort of maths, but there's a closed form solution for the m's and x's and the g's. It looks like this. It's kind of cool. From like eigenvalue theory. Is this something that you actually do at some point in maths and CS?
Yeah, we do eigenvalues. I'm not sure if I've come across this exactly, but
yeah, so once you've listed it as a matrix problem, you can, I don't know who I'm talking to here. If you turn it into a matrix problem, which chat didn't seem that keen on, you can diagonalize the matrix, and then then it's just powers of the eigenvalues. So these things inside the inner brackets are called eigenvalues of that matrix. They're super important properties of the matrix. It means that you get this kind of nicer problem to solve once you've processed the matrix a little bit, which gives you a beautiful closed form solution. G is particularly nice. So I'm not going to explain any of that on the question sheet or properly out loud, right? So this is kind of an advert for a degree. If you come and do a degree at university, then you might learn how you can go from those kind of weird expressions with lots of manual addition to, that's kind of a neat expression. I've also got 1 for the Fibonacci numbers. I don't know why I added that. That's not. It's slightly well known, I suppose. But there's a formula for Fibonacci numbers. Well, that's the best way of phrasing that. Not phrasing it like some sort of weird secret that I'm not letting anybody else have. The formula for Fibonacci numbers. Oh dear. It's 1.5 hours in is about the point where I stopped making sense. Lena, you're doing extremely well. You're still making sense. Slido won't let you edit. Okay, right. Slido says after a while you're not allowed to edit your previous things. So someone in chat is trying to invent a protocol whereby they can edit comments to reveal that they were, like they put some sort of hash code in or something so that they can reveal that they were the same person both times. It's sort of like cryptographic thing, I think. But being let down by the technology. You see this on forums sometimes. You get you can have people with unique usernames where they can prove it, but then they can. I'm way off track. Right. We got more words. This time they're called AB words. And we got some rules for generating them. We start off with just a couple. And we end up with quite a lot. I'm trying to work out, shall I just drop you in this? Do we need to say something at the start, or should we just start applying rules?
Yeah, I think it just wants you to start applying the rules and then keeps on adding more and more rules. But yeah, so the first bit of this question, well, if you look at the rules, the first rule is that if we have a word X, then we can write it as AXB. So it's quite similar to the question before. So I'm just going to write this as a note form. So rule 1 is that for word X, word X can be written as AXB. And now for rule 2, we just want to show that if there is a word XB, can be written as X. So we can just get rid of that last B. So now with these two rules, it asks us to show how we can produce the word AAAB. So we can use rule 1 3 times. This gets us A, B, B, B. And then if we use rule 2 2 times, we just get rid of these two B's and we end up with the word we wanted. So now we can move on to the next bit. And the next bit says to describe precisely all the words that can be produced with these two rules. Justify your answer. You might like to write A to the I for the word containing I consecutive copies of A, and similarly for B. So for this, we can start with the empty word. So if we have nothing to start with, then we can apply only rule 1 to this word, or rule 2 in future. So we can apply rule 1 so many times, and we'll apply rule 2 so many times. And rule 1 is going to get you add 1A and add 1B. And rule 2 is going to subtract 1B. So we can only decrease the number of B's or add 1A and 1B. So the number of B's is always going to be less than or equal to the number of A's. So, and with these rules, all the A's are going to be at the start, all the B's are going to be at the end. So we can write this as A to the I, B to the J, where I is greater than or equal to J, and J has to be greater than or equal to 0. And this gives us all of our different words. And now, as chat following this, is this
I think we're
okay?
Good. Chat is now talking about the Fibonacci numbers, if I'm honest. But I think it's a good example, right? That AAAB, the way you make it is you write down some A's and B's, and then you get rid of some B's. So you're going to end up with at least as many A's as B's, maybe the same number, but not more B's, because you only get rid of B's after you've written them, and you can never get rid of those A's you had on the front. So I think this is a good kind of warm-up part of the question where they give you a really helpful example. If part 1 was show how the word AABB can be produced, it would be very boring and easy, and also wouldn't set you up well for this idea that you can produce other stuff by knocking off B's from the end. Yeah, I think chat's okay. Good. Chat is occasionally, I don't know what it's like for people at home, but chat is occasionally freezing up for me and not showing messages for quite a while. Or maybe it's just like that today. I don't know. It's a weird day. It was sunny, then it wasn't sunny. Oh, sorry. I'll stop talking. There's a new rule. It's reverse and replace. But unfortunately, they haven't used M and W, so I can't refer to this as rotating the word about the midpoint, which is very sad. It makes me want to rewrite this whole question with M's and W's and put like modified at the top so that we're doing this different version. Very sad, but we've got a new rule now, which presumably means we can make more words. Over to you. Which words can we now make?
Yeah. So now with this new rule, we can. We still always have the A's in front of the B's if there are any A's. So we're always going to have A to the I, B to the J still. And this is because we reverse the word. So all the B's that were at the end are now at the front, and all the A's that were at the front are now at the end. But then we swap all the letters around again. So essentially, you're just always going to have B's at the end, A's at the front. But for example, now you could have the word A. And if we reverse this, replace every A by B, this is going to give us B. D. So we could have I being 0. And also, if we're reversing the word and replacing every A by B and every B by an A, then from this example and this example, we can have more B's than A's, but we're still always going to have, we can also have more A's than B's still, because rules 1 and 2 are still there. So basically, we've just got a bit less rules now about I and J. So it's just that I and J are greater than or equal to 0.
Cool. More rules about the words you can make leads to fewer rules, fewer restrictions on how many what restrictions for I and J for what's coming out at the end, I guess. It seems really weird to me somehow that. Sorry, go.
That's.
It just seems weird to me that you do these two switches. You do the reversing and then the flip A's and B's, and it comes back almost the same format. A's first and then B's. It's sort of, I don't know, it's sort of hard to imagine that. This thing on the right doesn't look like the thing on the left at all. I guess I'm just not good at imagining the A-B switch. Maybe if it was M's and W's, it would be easier to imagine. I'm just going to write it. You keep going. I'm going to write out some M's and W's on the right-hand side to kind of satisfy myself. We've got one more rule. I think if chat's not happy about this, then I'm going to get them to note that this thing over here has got more B's than A's, and you can do that in general now. One more rule, and it's a complicated one. It's just reverse the word. Okay, over to you, and I'm going to separately. We've never done this, writing two different sorts of math simultaneously. But you get to talk as well, so people will listen to you.
So now we're able to reverse the word, and it now says that you can get any word of A's and B's. So we want to prove this, and if we use the hint, it says if we have produced the word W, we can produce the word AW and the word BW, and then we can deduce the result. So if we start to think why, if we can make AW and we can make BW, that we can make any word. So it's just because if we have a word, some word W dashed, if we just build it up from the back and then add A's and B's, we can make this word consisting of A's and B's just using our method to get AW and our method to get BW. So then we can make any word of A's and B's. So we have already deduced the result, but we still have to do parts A and B. So for part A, to produce the word AW, we can just apply rule 1. So this gives us AWB. And then if we apply rule 2, then we get then we get AW, and then we are done. So this proves part A. And now for part B, we want to get BW. So to start this, we're going to introduce some new notation. So W bar is going to be our W with all the A's replaced with B's. So not reversed though, just A's replaced with B's. So if we call this W bar, then W bar is going to be just W, because we replace all the A's with B's, B's with A's, and then we re-replace them. So it's just going to be the same thing. So if we use this fact, then we can aim to try and get rid of this, because we're going to have to use rule 3 for this part of the question. So if we start by using rule 3, then rule 4, we are going to get on W, we are going to get a W bar, because it's W bar reversed, then re-reversed. So it's just going to be W bar. And then we apply rule 1. So we get A, W bar B. Then we apply rule 2 to get A, W bar. And then we can use rule 3 and 4 again to bar this. A, W bar, all barred. So this is equal to, we can just split these apart, W bar bar. So this is going to be B, W, and that is what we were aiming for. And then we have the result from this.
So watching along, I like the introduction of bar. I didn't think of that. The solution that I've put on the MAT Live website has got loads of words to try and explain that concept. And I like it. Is this? I might get you to explain how you thought of this in a second, but I think your best idea possibly is to do 3 then 4 as like one unit. And you've got a name for that, and it's your bar, and it's like combining 2 of the rules together, which seems pretty powerful. How did you think of doing rules 3 and 4 together?
So rule 3 on its own is quite difficult to think about. You have to reverse the word and replace the A's and the B's. It's just quite a lot. It seems like a completely different word to what we started with. So
I've been struggling to understand how that can produce what happens when you do rule 3. Sure, okay.
So yeah, if we use 4 then as well, 3 then 4, then you just end up with the A's and the B's switched, which is a lot more easy to work with. And we also we know we can get a W, but we wanted to be able to switch the A to a B at the front. So if we use the 3 then the 4 to get our W bar, then we can get rid of the problem that you can't get just a single B at the front. We can then just bar everything.
Yeah, so the only reason you would do, so I'm going to doodle on your working out to try and analyse what's going on in your mind, which is, you're right here, so it's kind of rude. The only reason you would do this is because you've had the idea already about where you're going, right? Or maybe you try this on a rough bit of paper or something, you're like, aha, if I put the A on and then flip it. But oh no, if I put an A on the front and then flip it, I'll get B, W bar, W flipped. But you've sneakily got around that by starting with W bar. It's like,
yeah.
So it's like some pre-processing that you realise you need to do this pre-processing, not because you're omniscient and you've seen where this is going. I don't know, maybe, but you maybe try out putting the A in front and then doing a kind of 3 and 4 switch to switch it. Unfortunately, that switches all of everything, but you get around by switching it first. You can prepend A or B onto any valid sequence as empty as valid. You can backwards form any sequence using all these rules as required. Yep, there's the last step, which is a little bit like induction again, but not really. It's like building things one letter at a time.
Yeah.
How do you think? So I suppose visually, perhaps you see that rule 4 and it starts with the same 3 words as rule 3. And maybe you remember that if you reverse something twice, it gets back. So maybe you have this idea that if you've written 3 then 4, which reveals you're thinking about it like that. But if you thought about it as 4 then 3, 4 then 3 would be reverse it, then reverse it again, and then replace the A's and B's. So your sequence would go flippity flip, and then replace the A's and B's.
Yeah.
So there's. Yeah, maybe think about it in that order. I don't know, but you've had the good idea of combining together rules 3 and 4 into one superpowered tool. Sometimes I get a little bit nervous when you invent something like that. Or you invent I'm just going to think about rules 3 and 4 to like reduce their mental processing to just have like some shorthand like rules 3 and 4 together do no reversing, just flipping. Sometimes you get a bit nervous because if you fuse those together, then you no longer have the ability to reverse words. And what if I need that later on? So you maybe have like a tiny bit of mental load to keep track of the facts that you could. You did this kind of sticking rules together. Over here, you could stick together rules 1 and 2. Now that you've seen they work really well together to put an A on the front, you could fuse these ones together. But I guess you've mentally you're keeping those a little bit separate as a two-step, or perhaps that's how you've laid it out, right? There's always a difference.
Yeah, you're right. Yeah, it would have made more sense to fuse them as well in the second part as well. Then you could have just seen it as adding the A on the front.
Right. So yeah, maybe it gives you a more elegant solution in terms of writing, but maybe harder to understand how you thought of it. There's something that I've been trying to think about and battling a lot is that the more you explain something, the more refined it tends to get. You tend to cross out your first idea and write something neater and tidier. So to try and make the MAT Live Solutions pages as authentic as possible to what I was thinking when I was doing the questions, they're not refined at all. They're just really rough and terrible and have typos in. I haven't gone back and made them easy to understand at all. Yeah, that's a way of justifying not doing the work, right? In chat, somebody says, I'm going to throw this to you, I think. Sorry, Lena. I feel like this is a badly defined system because you can refine 3 and 4 to a new pair of rules. Rule 5, just swap the A's and B's, and Rule 6, just reverse the order. It's a nice sort of simple... Oh, sorry, that's... Rule 6 then is the same thing as Rule 4, but just to replace Rule 3, replace it entirely with a new rule that just says replace the A's and switch the A's and B's.
Yeah, I think that is true. It would have been a lot easier to think about if they wrote the rules like that. I guess the reason they wrote it like this, I assume, is for the part I of the question to make, because if we had replaced the every A with B and every B with A as Rule 3 instead of the rule we've got, then I guess you would have words like B, 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 A already, which you can get at the end. So you can get any word at the end, but that means you'd be able to get any word already at this step, which I assume they didn't want in the question.
It does make the middle step, part 3 with Rule 3 is, it's hard to see how that would be an interesting question if the rules were too simple. And I kind of agree with the chat. Like, I suppose what they're really doing is giving, drawing attention or giving a name, perhaps, to 3 then 4 to call that 5. So not just constructing words from words, but constructing rules from rules. We've got a kind of meta level thing going on here. Good stuff. Okay. We've hit the end of this question. There's a good question in chat, which is, do these hints appear in the actual mat? And ones like this, yes. Sometimes there's hints in the questions. Where it says see the next page for hints, those were written for the MAT Livestream material. So if you want to see extra hints, and then you can download those about a day in advance. I put these online a couple of days ago. So yeah, sometimes MAT questions have little hints in. Or how to do the question, I suppose, in this case.
Yeah, definitely. I've used all of them when I was doing the mat. The hint is like, you need it really to do the question. Well, I suppose there are other ways to think about it, but if they've given you a hint, it's because it's going to be like a very much easier way to do the question if you look at their hint.
Yeah. Behind the scenes, perhaps this question started as just show that every word can be formed using these 4 rules without a hint, and that's much harder. Having that idea is really tough. So maybe people working on the question thought, people aren't going to have this idea, we should give them a hint and check that they can follow through with the idea, which is still a useful skill, being able to follow through on hints that you're given. Something we do in interview as well. You could imagine a world where this question was just, well, So the question could be, if you're making it very elegant, the question could just be, here are the 4 rules, prove that any word can be made. But that's extremely difficult, even though it's the same thing, right? In the end, the steps along the way are kind of sometimes just carefully designed so that you get to a cool thing at the end, even if that means ruining one of the rules. It's not obvious, right? The rules are A and B, A on the front, B on the end. Remove a B from the end, or reverse it, or flip all the A's and B's. Reversing and flipping clearly doesn't help me very much to make everything. Adding A's and B's feels quite restrictive, and just removing the B's feels like, oh no, now I have to consider. If I'm trying to make everything, I have to consider the case where I add lots of B's, do a flip and a reverse, and then remove some. Oh gosh, oh no. The words don't just get longer; sometimes they get shorter. So it's a complicated maze. The question is leading you through step by step a not obvious thing of how to make all words. Cool. Did I ask you how you chose your college? Oh yes, you did. You talked about it being friendly and happy. I'm just looking at all-time chat messages. If I fail the personal statement, says Cyril in chat. Cyril, for maths and computer science at least, I know that personal statements don't get given a pass-fail grade. They don't get given a number score. I've never seen a personal statement that made me not want to take a student. Everybody's personal statement, I read them and I think, yeah, seems like a good student. Can you remember what you put in your personal statement, Lena?
I think I mainly wrote about, I'd done a summer school of maths somewhere, so I wrote about that, but I didn't write too much about it. It was more about what I'd done after that because of the stuff. Like, I think that's mainly what they want. They want to see how you follow up on what you do. So if you've read a book, how did you follow up on that? What did you find interesting about it? And how did you read further or look further to explore it further?
And as a tutor, that's why I'm putting extensions onto some of these questions, so that if somebody likes a particular question, that maybe they can go and think about it a little bit more afterwards. Because YouTube videos, you can watch the YouTube video and see someone else do the questions, but I read this in a book recently. Someone said, watching somebody else do maths is like watching somebody else lift weights. It doesn't actually make you very much stronger.
Yeah.
If you want to see my personal statement, or maybe just the first sentence, at one point the live stream convinced me that it would be a fun thing to do to read out my actual personal statement on the stream. You can see that on this YouTube channel at some point. It's a terrifying number of people have seen my personal statement. It's really bad. It's very, very cringe. I'm sure yours is less cringe than mine. Did you do A-level CS? I should have warned you. Chat always asks about A-levels. They're really interested in what A-levels people are doing. Did you do A-level CS?
Yeah, I did. Yeah.
What's that like? Is it like university at all? I didn't do it, and I don't know what really was in it.
I found it very different to university math. Computer science, I found university computer science was a lot more maths based than the A level, but I think that the coding, the practical in at least the A level that I did, the computer science A level, was quite write-up based, whereas at university it's less write-up, it's more here's my code, and this is like, you write very short and very to the point what your code does and show it, rather than, I remember writing long paragraphs about why I chose this color scheme, and that doesn't come up much at the university, at least not at the moment.
Maybe not, yeah. Someone in chat wants to know how much computer science you put in your personal statement. What sort of mix did you go for? You were applying for maths and computer science.
Yeah, I think I put a bit more maths in than computer science, just because I'd done more maths. I feel like, well, I'd seen more maths events available than computer science events. So I'd done, but I think it doesn't really matter. I think probably about a third, two-thirds I did. But as long as you show that you're interested in computer science, like if you're doing a joint degree at least, then as long as you show you're interested, then it doesn't matter what exactly balance you've got.
Yeah, computer science as opposed to. I found someone else in chat who's doing. Cyril is doing A-level computer science. Cyril says maybe you can agree or disagree. They don't teach you programming or maths, mostly it just comes to actual hardware, registers and CPU and logic gates. I know nothing about hardware, so gosh. Is there any hardware stuff in the degree course?
I not in my course because I do the maths and computer science joint degree, so I don't actually have to do any of the hardware. But I know there was a compilers course for, not sure if it's this year or next year, for straight CS students, and you can choose to do slightly more practical courses in third and second year.
A lot of cool stuff when you get down to that level, but a lot of incomprehensible. It sort of becomes less human to me. To my point of view, it becomes less human the more layers down you go. I guess that's why I'm stuck using MATLAB. Right. Okay, we've hit 7 o'clock, which means I should let Jackie in chat go. Thank you, Jackie in chat. And I should let Lena go as well. Thank you for coming on the stream. Thank you for answering so many Matt questions. It's been a really fun 2 hours. Thank you for watching, everyone at home. Plan for next week and the next few weeks is we're going to switch to looking at entire past papers. We're not going to go through every question on a past paper, but we're going to have some time, technically, for each past paper. So if there's a question you really want to ask about, there is some of the MAT Livestream assigned to that paper. We're going to do polls to work out which questions we're doing. We're going to do probably some maths again if you've been overwhelmed by the computer science of matrices and eigenvalues. We're going to go back to 2007, a very good year. Good. People in chat want advice for personal statements. I think you've said quite a bit about personal statements, about writing about what you're interested in and what you're up to, which I think works really well. Note for next week, if you want to look at the past papers before, I think it's a good idea. If you want to get a little bit ahead of me, you can now get as far ahead of me as you like, because from now on we're doing past papers, so you can decide how you want to play that. If you do them before, you might not want to, I don't know, up to you whether you want to try papers before and then watch the stream or just watch bits of the stream afterwards. If you're here live, you can help influence which questions we actually talk about on the live stream. If you watch the replay, obviously you don't have that level of control over my life. Right, bye everyone. Okay, we're going to call it there, and we'll see you in 166 hours for another episode of the Oxford MAT Livestream. Take care, have a good evening. Bye.
Bye, thank you.